So now we're going to talk a little bit about host resistance to viral infection. This is very similar to the host response to a lot of different other agents. Your innate defenses are going to be very important here, including the skin. There are really not a lot of pathogens that can penetrate intact skin. There are a few parasites that we're going to talk about, but most things actually need a cut or break in the skin to gain access to initiating an infection. And viruses are really no different. The acidity of the skin is also a helpful innate barrier. Again, that has to do a lot with your normal flora. The last one listed under primary defense is the mucociliary elevator. And again, this is also very helpful. We've got your cilia beating, and anything that comes in, it doesn't like, it's too big, bam, it kicks back out, okay? Now, specific immune defenses that are not part of the adaptive immune response, okay, include interferon, which we're getting ready to talk about, which is a really cool thing that happens when cells get infected with a virus. Complement can also be helpful for battling viruses, but in general, complement, its main function is in inflammation, okay? So again, it can help with the inflammatory response, recruiting other cell types to the area, and then natural killer cells. It's always good to have a backup plan, okay? We know for viral infections, we typically think about the cytotoxic T cells, but don't want to forget about the natural killer cells, which, although they don't specifically find target cells that are infected with viruses, they still have an antiviral defense property. Then, of course, most important for really any infection is going to be your adaptive immune response, your humoral and cell-mediated immunity that translates into antibodies and your cell-mediated immune response. We're going to talk more specifically about that when we move on to immunology. Now, interferon production is really a cool thing, okay? So what happens with interferon alpha and beta, okay? There are three different types of interferons, alpha, beta, and gamma. Gamma does something completely different. So you need to know that alpha and beta are your antiviral interferons. So that's the first thing. Now, what happens is with interferon, let's say you and I were all a big bunch of cells, okay? And I get infected with a virus. And for whatever reason, I like you, you didn't make me mad that day, I can protect you, I can help protect you against that viral infection, even though I'm going down. You know, I'm probably going to be the one that dies. But in doing so, I'm going to make interferon, I'm going to pass it around, and you're all going to grab it. And in doing so, you are going to be protected against the viruses that are about to blow me up and try now to attack you. That's what's really cool about the interferons. Now, what they do is, again, they're going to act on really neighboring close-by cells to inhibit viral replication. But here's an important point. They are not viral specific. What I'm going to do is, remember, I have the viral infection, okay? And I know I'm going down, but I'm going to make interferon and I pass it on to you. When you grab that interferon, what you're able to do is shut down temporarily protein synthesis, okay? So now, when I get blown up and the viruses leave me and come to attach to you, they can attach to you, they can get into you, but they can't replicate in you. Why? Because you've shut down protein synthesis, and they need your stuff to replicate their proteins, okay? So, they don't act directly on the virus. They're not viral specific, but they are species specific. So you have interferon made in each of the different species that are specific then for those species, okay? Now, interferon, we said, inhibits protein synthesis. Now, the fact that it inhibits viral protein synthesis is a bonus. Remember, it's not specific. You got two different mechanisms, okay? One of which is by inducing the expression of an RNase. If you have an RNase, what's going to happen? You're going to chew up the RNA. You can't make protein without RNA. The other way is by activating a protein kinase that interferes and inactivates initiation factor, okay? So, in the first way, we've got an RNase that's going to chew up the RNA. In the second mechanism, we are activating a protein that's basically going to interfere with translation. Either way, you're not getting any proteins made. All right. Now, interferons, what's cool about interferons is that we can use interferon in the treatment of certain viral diseases. We typically, right now, use them to treat active hepatitis B and C, and also chronic infections with hep B and C. So now I'm going to show you a little cartoon diagram of how interferon works. All right. In the example that I gave you before, I was the original virus that got infected. So here I am over here. Okay? And here you are over here. What happens is I get infected with this nasty little virus. I know I'm probably going to die, but I'm a nice person. So I start pumping out interferon. And here it is down here. Here's the interferon. I'm going to secrete it. You're going to grab it because that's your ticket to live. And when you grab that interferon, you're going to actually shut off temporarily protein synthesis. So now I'm blown up. I'm gone. The viruses that are leaving me come and attach to you. They get inside you. They try to replicate. Denied. They are denied. So what happens at that point is that the viruses are going to come in. You're not going to allow them to replicate. When the threat of the virus is gone, you're going to resume normal protein synthesis. So you're not going to die. You're just going to temporarily shut it off. So the cells that are coming in aren't going to be able to replicate in you. And then, when there's no more virus around and you're pretty sure it's safe, you're going to turn it right back on. It's pretty cool. So I just want to mention some of the therapeutic uses, again, of interferons. Interferons, okay, can increase the expression of class 1 and class 2 MHC. That is also helpful in clearing of a viral infection. And they can increase the efficiency of presentation of antigens, therefore to cytotoxic T cells and T helper cells. I just want to talk specifically about some of the different interferons that are used therapeutically. Interferon alpha is the specific interferon that's used to treat a lot of the hepatitis viruses, hairy B-cell leukemia, CML, and Kaposi sarcoma. Now, interferon beta is used to treat actually multiple sclerosis, and it has been really revolutionary in individuals with MS. It will not allow them to go back. In other words, if they have lesions, the treatment with interferon beta won't clear up those lesions, but it will prevent the development of more lesions in the CNS. So that's been really helpful. Interferon gamma, which really is not one of the interferons that we just talked about. Interferon gamma's main job is to activate a macrophage. Interferon gamma can be used in patients with chronic granulomatous disease. And we'll talk about that a lot more when we hit the immunology